Hi. In the last video, we learned that the simplest way to move from a single agent system to a multi-agent system is with the help of a router. So when a single agent has too many responsibilities or tasks or roles, it gets overwhelmed, and for that reason, the performance of that agent drops. When we realize that the performance of the agent has dropped due to having too many responsibilities, conflicting or unrelated responsibilities, in that case, we try to devise a multi-agent system and we use a router pattern to be able to do that. How that happens, we saw that the user sent the query to the router. The router directs the query to one of the agents available to it, and that's all. It's a single step system. Router uses either a language model or one of the traditional models to classify the query into one of the agents, and it's done. But what if the query is too complicated and it needs the help of more than one agent to be able to answer to the user? In that case, the router becomes useless because it does classify the query into one of the agents only and only one time. So the queries that are more complicated could have something like a number of steps. For example, you can take the example of a query such as in the e-commerce system that we talked about in the last video. You can consider a customer complaint received via email. So the AI system needs to answer the customer by first understanding the customer issue with the help of that email, then looking up the order history of the customer, return history of the customer, looking at the profile of the customer, then trying to solve the customer problem using refunds or providing some of the benefits to the customer to be able to solve the customer problem, and then writing a solution to the customer, summarizing the solution, maybe translate that solution or the email to the customer and then send it out. So the problem that we just described actually needs more than one steps and more than one agents in different steps. One of the steps might need just a summarizer agent. One of the steps might need just lookup agent or refund agent and so on, billing agent. Now these problems that are unrelated need different agents, more than one agents to be able to answer this query. So what happens in this case is router is not useful and we have different pattern called either a parallel or pipeline pattern. This could be also considered as a sequential pattern. So let's talk about pipeline first. So pipeline is essentially a series of steps performed sequentially. So step 1, step 2, step 3, step 4. Each step only happens after the last step is finished and it takes the output of the previous step. That's why all the steps have to happen in sequence in such a case. However, in some cases when the steps are unrelated, they can happen in parallel to each other. In that case, we will use a parallel pattern to save latency on the system. So, we just briefly discussed parallel and pipeline patterns, which is an improvement over router. Why? Because in these patterns, we can essentially use different agents in different steps. And we don't need to use just one agent. So, for those complex problems that could be solved with the help of different steps, we will use one of parallel or pipeline patterns. There's one important thing about parallel and pipeline patterns is that the exact steps need to solve that particular problem have to be defined well in advance while architecting that system. Who does that? Basically, the software engineer or the architect who's designing the system takes care of deciding these steps and assigning different agents to each step to be able to solve this problem. So basically, the whole flow of data from step 1 to step 2, step 3, let's say some steps happen in parallel, some steps happen in sequence. Step 1, 2 and 3 happen in parallel, step 4 happens in sequence. Basically, this whole design happens in the design time and not in runtime. There are some problems for which there couldn't be any predefined steps. They are more complex. One such example could be, let's say, I have a problem in which research the competitors and design the memo for the CTO of a company. For such a complicated problem, you can never decide the steps in advance. So what happens in such a case is you use something known as an orchestrator pattern, about which we'll learn in the next video. Basically, this orchestrator pattern works on this particular weakness of the parallel or pipeline pattern. It's more advanced than router, then there's parallel or sequence, then there's orchestrator. So orchestrator essentially decides these steps, designs the whole plan in runtime and not in design time. So it's more useful for more open-ended problems. So in the next video, we'll learn more about orchestrator, but in this video, we got a good understanding of parallel and sequential patterns that have been an advancement over router pattern, in that we can use multiple agents to be able to solve a particular problem or answer the query of a user.